Imagine this. One night, a new star suddenly appears in the sky. It rivals the brightness of the moon. For weeks, it outshines entire galaxies before slowly fading away. What you've just witnessed is one of the most violent and awe-inspiring events in the universe. A supernova, the explosive death of a star. These explosions aren't just spectacular light shows. They are the cosmic forges that made the calcium in your bones, the oxygen you breathe, and even the iron in your blood. Without these supernovae, we quite literally wouldn't exist. Stars are colossal balancing acts. On one side, gravity pulls matter inward, trying to collapse the star. And on the other side, nuclear fusion in the core pushes outward, creating pressure. For most of a star's life, these forces are in perfect equilibrium. Unfortunately, nothing lasts forever. When a star runs out of fuel, that balance becomes broken. And when gravity wins, the results are spectacular. Let's start with massive stars, at least 8 times more massive than our sun. These stars live fast and die young. They spend millions of years fusing hydrogen into helium, then heavier and heavier elements like carbon, oxygen, silicon, until finally, iron. Here's the catch. Iron doesn't produce energy when it fuses. Instead, it acts like a dead end. Once the core is mostly iron, fusion grinds to a halt. The star suddenly loses its precious fort, and gravity takes over. The core collapses in less than a second. Imagine a sun's worth of matter imploding into a ball just a few dozen kilometers across. It's like squeezing out Everest into the size of a sugar cube. Temperatures soar to billions of degrees. And then comes the rebound. The collapsing core smashes inward and bounces back, sending out a shockwave that tears the star apart. That shockwave is supercharged by a flood of neutrinos, ghost-like particles that carry away 99% of the explosion's energy. In a single second, a core-collapsed supernova releases more energy than our sun will emit over its entire 10 billion-year lifetime. What remains of the center depends on the star's size. For many, the collapsed core becomes a neutron star, an object so dense that a teaspoon of its material would weigh 1 billion tons. If the star was even bigger, gravity crushes it further, forming a black hole, a point of infinite density where not even light can escape. Meanwhile, the outer layers are blasted into space at up to 20,000 kilometers per second. This debris will expand into colorful nebulae, like the Crab Nebula, born from a supernova observed in the year 1054. Within that expanding cloud, something magical happens. New elements are created. Gold, uranium, iodine, nickel, all heavier than iron, are forged in the chaos of the explosion. The atoms in your jewelry, your phone, even in your DNA, they were all born in stars that died long ago. Every breath you take contains oxygen that was created in supernovae billions of years before Earth was ever even formed. Not all stars that explode are giants. Some are white dwarfs, the dense embers of sun-like stars. By themselves, they're stable, but if one orbits another star, it can pull matter from its companion. If the white dwarf collects too much material and reaches about 1.4 times the sun's mass, it can no longer hold itself together. In a runaway reaction, carbon inside the star ignites, and the entire white dwarf detonates in a thermonuclear fireball. Unlike core-collapsed supernova, a Type 1a supernova completely obliterates the star. Nothing is left behind. These explosions are incredibly consistent in brightness, making them standard candles for measuring cosmic distances. In fact, Type 1a supernovas led to the discovery of dark energy, the mysterious force accelerating the expansion of the universe. A single Type 1a explosion shines as bright as 5 billion suns, and it does so for weeks. When the shockwave expands into space, it acts like a cosmic sculpture. The shock compresses nearby gas clouds, sometimes triggering new generations of stars. In this way, Supernovae both end lives and spark new ones. They're also natural particle accelerators. The expanding shot front boosts protons and electrons to nearly the speed of light, creating cosmic rays that zip across the galaxy and even reach Earth. Right now, at this second, dozens of cosmic rays born in ancient supernovae are passing through your body every second. During the collapse, neutrinos flood out of the core in numbers beyond comprehension, about 10 to the 58 particles in just 10 seconds. They travel unhindered across the universe, almost never interacting with matter. Astronomers have actually built a global early warning system for these particles. The next time a nearby star goes supernova, our detectors will spot the neutrino burst hours before the light reaches Earth. We will know a star has died before we even see it. So what if the supernova was to happen in our neighborhood? Supernovae are common in the universe, but they are very rare in our skies. On average, one happens in the Milky Way every century or two. And the last visible one was Kepler's supernova in 1604, over 400 years ago. So, what could it look like if one happened tomorrow? If Betelgeuse, the red supergiant 430 light-years away, were to explode, the result would be a once-in-a-civilization event. It would shine it as bright as the full moon for months, visible even in daylight. But at that distance, it wouldn't harm Earth, so you can rest safely. It would simply be the greatest natural fireworks display humans have ever seen. The only stars close enough to truly threaten life on Earth are more than 30 light-years away. And luckily for us, none of them are primed to explode anytime soon. Evidence shows that Earth has been touched by past explosions. Layers of deep-sea sediment contain radioactive iron-60, debris from a nearby supernova just a few million years ago. Some scientists even speculate that supernova radiation may have contributed to past mass extinctions by damaging Earth's ozone layer. The fingerprints of these events are written into the very history of our planet. So what really happens in a supernova? A star collapses, rebounds, and detonates with unimaginable power. It lights up the cosmos, floods the galaxy with elements, and sometimes leaves behind a neutron star or a black hole. It's violent, it's destructive, and yet it's also creative and beautiful. Every atom of gold, every molecule of oxygen, every drop of calcium in your bones, all of it was born in the death of those stars. The next time you look at the night sky, remember, the universe didn't just give us light to wonder at. It gave us the very ingredients of life, forged in fire, scattered by supernovae, and gathered again in you.